All right, so welcome to our first discussion of some actual chemistry topics. We're going to start out with the usual sort of first information for a science class, and that's basically just to define what chemistry is. You're going to hear a lot about this term and this definition sort of bouncing around throughout the year. It's really basic. Chemistry is the study of the structure and properties of matter. And at different times, we'll be looking at structure, and then later at properties, and then back to structure. Whether that structure has to do with the way an atom is constructed, the way atoms bond to each other in molecules, the way atoms form ions and bond to each other in ionic compounds. And properties, of course, we'll hear a lot about those things, all the reactions that people look forward to seeing in chemistry, how chemicals react when they get together, what blows up, what doesn't, what burns, what doesn't, why does this rust and this doesn't rust, why is plastic so awesome and yet kind of tricky as far as how we recycle it and if we do or don't do that. All kinds of stuff with properties as well. So it's a real basic chemistry definition. Chemistry being a science, lots and lots of science classes will start out talking about the scientific method, and we're no different here. We're not going to get too far into all the details on it and spend a lot of time necessarily looking at those up close. You've probably seen them in a lot of science classes throughout your years. But basically, we want to remember that in chemistry, like all science classes, all science at its root has to do with investigating and discovering new things, new ideas through experimentation. Science is all about answering the question, what will happen if we do this, or why does this happen? Why does this work this way in the universe? And so when we're looking at chemistry, it's no different here. I want to be able to understand why things react the way they do and why they don't react the way they don't, just as importantly. So it's investigation and discovery and answering the question why. The word science means to know, and so to know means to learn about and understand, so that you can know what the heck something's doing and why it's doing it. So we'll keep those scientific method steps in mind as we're investigating, as we're designing experiments, and you'll be doing that fairly soon with our first lab of the year, coming up with an experimental design of your own. Some things to keep in mind with scientific method. First of all, the first step of it is observations. When you look at something and wonder why it works or how it does what it does. You see it, you smell it, you hear it, you feel it, you observe it. Really generically, the word observing includes all those senses. Just about anything can be observed, and almost any of those things, if we look at it closely enough, can yield us a question or make us wonder something about why something does what it does. And so those observations are at the heart of it. And they'll be coming back again later during our experiment too. Step 2 of the scientific method is the hypothesis. You come up with a statement in writing a hypothesis that might explain what you observe or states what you believe will occur. Remember with a hypothesis that this should never be a question. Hypotheses are not questions. They are statements of fact. You say them as if they are true, and then later can prove your hypothesis true or false. You can support or confirm your hypothesis, or you can negate or show that your hypothesis was wrong. But when we state the hypothesis, we state it as if it were a true fact, and then later on we'll evaluate it after the experiment is over and we've made some conclusions. We'll evaluate whether or not our hypothesis was valid. And that's what the scientific method's all about. Again, importantly, it's not a question. So step 3 is the big one, the fun one perhaps, that people think most about and often want to jump right to in the scientific method, and that is to experiment. You test your hypothesis with a procedure, various steps of that procedure that you're going to take on and come up with. Along the way, you'll be collecting data and or observations. Data doesn't just have to be numbers. A lot of times we think it is, but data can be really any information that you write down, record, color changes, heat being produced, precipitates forming, and we'll talk more about what those are later. So any information that you record can be part of your data and or observations, however you want to classify that. You want to keep your observations organized neatly. We'll talk a lot about data tables. Lots of labs in chemistry have numbers involved, and so you'll need a data table to kind of keep those organized. So you want to keep your observations organized neatly. And you should always record more information than you think you'll need. It's always okay to have more things written down than you actually ever needed to have. The problem is if you don't write things down, record your observations now. Oh, that's not that important. I don't need it. Then later on, you don't have it. You forget it. Whether it's a day later, even just an hour later, some detail might escape your mind. Certainly days later, when you're looking at that lab again, down further down the unit, or even later in the quarter, semester, or year, you're going to forget things. And so it's always better to write those things down and have more information now than you think you'll need. Because you can always just ignore it later. If it turns out it wasn't important to have, you can just forget that you wrote it down and just sort of ignore it, have it there as extra. Better to pack too much for your trip than to not pack enough and wish you'd remembered to bring along something that you didn't. Conclusions, the last one, isn't necessarily, a lot of times with the scientific method, you'll hear people talk about the last part of the scientific method as theory or law. Those are pretty big steps. Generally, when we're testing a basic hypothesis in chemistry or any other science class, you're just going to evaluate whether or not your hypothesis was shown to be true or false, and if further experimentation is necessary. And I say here, it almost always is. Basically, if you're doing a real simple lab, you may not have to go back and repeat the experiment again, but in order to be really confirming your hypothesis or confident in it, you would need to repeat an experiment many, many times. This is why, for example, when they test a new drug or medication on someone, for people for various diseases or whatever, they don't just have one person try it, and if it works for that person, then it must be good for everybody. Or if it doesn't kill that person by accident, then it's probably safe for everybody. Medical tests use hundreds of different people over the course of many years, and they try different things about them, and different people with different factors, ages, all sorts of things, and they try to make sure that they're not going to miss anything. And so the same thing's true with us. If we were doing hardcore research like you might do if you're in a college program someday, for us, mostly we'll just do an experiment one time, sometimes repeat it twice or three times within that day, but usually one time through is enough to get an idea at least of the concepts. And basically the idea of conclusions then will be, as it says at the very bottom here, you just go back to the beginning of the scientific method and start again. Was your hypothesis good or bad? Those are your last experiment becomes the observations that start your next experiment. And then you create a new hypothesis if necessary and try that one instead. Go on through and kind of loop back again and again until you're confident with your results. So when we're testing experiments, we're going to be setting them up with what we call variables. And variables are really kind of a generic term for any sort of a factor that's involved in the experiment. There's going to be three types that I'll tell you a little bit about here. Those are independent variables, first of all, and then we'll talk about dependent variables and also control variables. So an independent variable, as it says here, is an adjustable factor that you control in the experiment. You should only have one independent variable in any given experiment. It makes it really difficult to test too many things at one time. If you end up having two independent variables or three, you can't keep track of what's causing what. And so let's say in this example, I'm building ramps for my radio control car to see how the car jumps off of each one. What might the independent variable be? So when you're setting up an experiment with a car like that, there are lots of things you could establish as your variables. You could adjust the speed of the car, but that wouldn't be having to do with the ramp. So you want to be specific to the ramp itself. So maybe you want to try ramps of different lengths. Maybe you want to try ramps with different heights where the car comes off the end of it. Maybe you want to try ramps of different material types. So make some out of wood, make some out of plastic. Maybe you try one out of cardboard. Any number of different materials that you might use. Lots of things you could adjust about ramps, and there's probably things that you could come up with that are different than this as well. You could get a little more geometry based and think about the angle of your ramp steepness and calculate things with that instead. So depending on what level your thinking is at, you could take this, make it pretty simple, or you could take it a long distance from there. So independent variables are those things that you're going to adjust and manipulate in order to cause something different, hopefully, to happen in this case, with the car coming off the ramp. And that something that's happening with the car, then, is our dependent variable. It's the factor that changes as a result of the independent variable being changed. So if I were to adjust in my car experiment here, if I were to adjust the height of the ramp as my independent variable and try maybe a ramp that's 4 inches high, 6 inches high, 8 inches high, something like that, you're going to see some difference perhaps in how far the car flies off the ramp and how far it flies before it lands again, which would be fairly easy to measure, or video record and measure on the video. So maybe the distance that the car travels would be your dependent variable, or maybe it would be the height that the car achieves. That would be trickier to measure maybe, but if you video recorded it, you could probably do that. Maybe the dependent variable would be the time that the car is in the air. That would be quite tricky to measure very accurately, probably by hand, but again, if you used a high-speed video, you could sure do that. Or lots of things like that. You could maybe even make a race experiment here with a car where the car comes off the ramp at different heights and you have it landing in, say, a bed of flour or sand, and you could maybe measure how deep of a hole it makes in the sand when it lands, or how much sand is splashed out of the container that it's in, something like that. So there's all kinds of them. Think outside the box. Don't get trapped with the same dependent variable that maybe your neighbors thought of because you overhear them saying it and think, oh, that's a great idea. Let's do that. Think outside the box. There's almost always something more impressive to think about and measure as a dependent variable if you just give yourself some time to think about it. And then our last variable is called a control variable. So this is one that's kind of overlooked or forgotten at times. A control variable is not quite the same as your experimental control, which you've heard about probably in a biology class or other classes where it's a whole different meaning there. I'm not going to get into that now because I don't want to confuse you. A control variable is still a variable. It's something that you could change, but you're not going to change in your experiment because you want to keep them the same consistently throughout. This is kind of going back to the idea that you only want one independent variable at a time. The other things that you could have made independent variables all should stay the same. And so in our example here, we're talking about our race car experiment. Let's say that I decided my independent variable was going to be the height of the ramp where the car comes off the end of the ramp. My dependent variable was going to be how far the car travels through the air before it lands. The control variable then could be the length of the ramp. It's always going to be 24 inches long. Or it could be the material that the ramp is made of. It's always going to be the same plank of wood, or the same sheet of balsa, or a piece of cardboard, or a piece of plexiglass, or something. Another control variable could be the width of the ramp. It's always going to be 6 inches wide or 12 inches wide. You could also adjust the speed at which the car is coming onto the ramp and hopefully coming off of the ramp, because obviously if you're not keeping your car's velocity or speed the same for each trial, that's going to be a huge impact on how far a car flies too. So a control variable can be overlooked and forgotten in your experimental explanations or your experimental design as you're doing a lab write-up. But in fact, there's often a lot of control variables that you kept constant without realizing it. It's probably those are quite easy to come up with afterwards. But as you're designing an experiment, it's really important to keep these in mind in advance, because if you didn't consider the speed of the car, for example, and you didn't manage to keep the car's speed consistent for each jump, after you're done, you're looking at your data thinking, oh my, that could have been a big factor here. We better go back and start all over again. So if you think about control variables and plan them out really well in advance, you don't ever have to go back and restart your experiment, at least not for this reason anyway. And it's something that you'll have covered and taken care of in advance. Really, really important. That's it for this section. If you need to go back and watch it again or take the notes better the second time around, feel free to do that. We'll be back next time with observations and interpretations, and then we'll start talking about how to make good measurements.